Okay, so we're on page 269. We're going to be talking today about one of the pretty important lessons of the year. I don't think it's the most important. The most important, I keep saying, is Pythagorean theorem. But statistically, this is what 8th graders do the worst at. Okay? Again, I don't understand why. They also do pretty low with volume, but I feel like for the most part, you guys did pretty well with volume. This is very similar with volume in the fact that all you need is the formula. Okay? What we're going to be talking about today is surface area. Yay, yeah. We introed this a few weeks back, but we're going to actually get into the lesson today. Now, there are two different types of surface area. Okay? The first, and let me get a better color here. The first is lateral surface area. All right, you'll see me put it as LSA a lot because I don't want to write that whole thing out. LSA. All right. Again, all of the formulas are going to be given to you on the formula chart during STAR test and anytime you're taking tests in here. Okay, so you will have these formulas. The formula for lateral surface area is that right there. All right. So, what do you think H stands for? Height. Okay. Height of the prism, the distance from base to base. Just like we talked about with volume. What could P stand for?
Area of the prism. Perimeter.
Perimeter. All right. But it's a capital P.
Prism.
It's a capital P. So what?
Like perimeter of all sides.
What does the capital B mean?
Area of the base.
Area of the base. What do you think the capital P means?
Perimeter of the base.
What?
Perimeter of the base.
Perimeter of the base. You can't do area of a perimeter because it's a straight line. Right. So, capital P, just like capital B, capital P is the perimeter of the base. Okay? So those capitals should stand out to you. All right? The other kind of surface area, and before I explain what they mean, I'm going to kind of see if you can figure it out based off of the formula. The other kind is total surface area, or TSA. Okay, and the formula for that is capital PH plus 2 capital B. Okay, all right. So before we get into the difference between lateral and total surface area, let's talk about what surface area is. I know we've talked about this before, but I just want to make sure we're all on the same page. The best way that I can explain it, volume is how much paint would go in a bucket, right? If you had a bucket, volume is how much paint it holds. Surface area is how much paint it would take to paint that bucket pink. Okay? It's the surface. It's the outside only. It's nothing to do with the inside, right? When you're thinking of painting a house, do you worry about the inside of the house? No, we're talking about just the outside walls, right? Surface area is exactly what it sounds like. It's the area of all the surfaces. Does that make sense? So, when we're looking at lateral surface area and total surface area, right, what can you tell me is the difference in those formulas between lateral and total surface area?
Lateral is the perimeter of the bases times height.
Mm-hmm.
Total surface area is the perimeter of the base times height plus 2 times area of the base.
2 times area of the base. Good. So what does total surface area have that lateral surface area doesn't?
Perimeter.
No, they both have perimeter. Somebody said it. It has, yeah. The total surface area has the area of the bases, right? How many bases does a prism have? 2. Okay. So total surface area includes those 2 surfaces. Lateral surface area doesn't include those 2. Okay, so let me draw an ugly picture here. All right, let's say we have Something like that. Isn't it just beautiful?
That's amazing.
All right, so lateral surface area. All right, we'll start out with total surface area. Total surface area has this and this. Well, I'm sorry, I'm going to start with lateral. Lateral surface area would be the perimeter of the base times the height. And what that does is it covers all of these edges here. All right, there's two more that we can't see, right?
On the other side?
Mm-hmm. On the other side of the box, yes. So lateral surface areas, and make sure you hear this, this is important. Lateral surface areas are the surfaces, oh, that's not how you spell surface. There we go. Surfaces that connect the bases. Okay? The lateral surfaces are the surfaces that connect our two bases. Okay? We can look at this prism that I've drawn and we can see that there's two bases, right? The top and the bottom. Okay? The lateral surfaces are the four sides that connect the top and the bottom. Okay? So when we're talking about lateral surface area, it's almost like a plumbing pipe. Okay? It doesn't have ends, right? It's hollow, going all the way through it. Okay? You've seen metal beams that don't have anything going through the middle, right? There's no caps on the end. It's just the outside part. When we get into total surface area, now we have capital PH. That's just our lateral surfaces, right? The capital PH, that covers the four surfaces on the outside. Then we have 2 times the area of the base. That adds our two bases on the top and on the bottom. So now we're looking at every single surface. Okay? So the big thing to remember, lateral surfaces do not include the bases. Total surface area does. Okay? And the good thing is, like I told you, you get these formulas on the star. Okay? And so if you can't remember, if you look at the formulas, it kind of tells you. Lateral surface area, okay, I don't know what that is, but I can see, hey, total surface area has the two bases and lateral surface area didn't. And that should lead you through. That should give you enough information. Okay? All right, so let's actually look at an example here. Maybe it'll help clarify a little bit more. All right. Let's say that this is 5 inches. This is 6 inches. This is 12 inches. All right. We're going to solve for the lateral and the total surface area of this prism. Okay? So, we have lateral surface area, the perimeter of the base times the height. Now, we've talked about this before. The base is always the shape that it's named after, unless it's a rectangular prism, which is what we have here. On a rectangular prism, which is the base? The bottom and the top. All right, those are going to be our bases. So, the first thing I need is the perimeter of the base. That would be here, here, and then around, right? Mm-hmm. So what's the perimeter of the base? How would I find it? You would, okay, 12 and 6 make 18. Plus another 12. Do you have calculators? If you do what? I'm adding around the perimeter is when you add around the outside edges.
So it's 12 plus 12 and 6 plus 6?
So 12 and 6 make 18. Another 12 makes 30.
36.
36 overall. Does everybody know what perimeter means?
Yes.
Okay. We're just adding around the outside. There's 4 edges on the base, right? We add the 4 edges. That's all it is. Okay. So we get 36 as our perimeter. What's the height of this prism?
5 inches.
5. Okay. 36 times 5 is 180. That's our lateral surface area.
So it's kind of like
Coach, it stinks in here.
Sorry. All right. So that's our lateral surface area. It does not include the bases. So now let's look at the total surface area. That's going to be perimeter base times the height plus 2 times the area of the base. So now, perimeter is going to be 36. The height is going to be 5. We just solved that, right? Over here. So I'm just going to plug that in. The perimeter of the base times the height is 180. We already know that because we just solved it. Plus 2 times the area of the base. Okay? That's the area of that bottom rectangle. How do you find the area of a rectangle? Length times width or base times height, either one. Okay, and so we're going to do 12 times 6. Because those are the 2 numbers that go with our base. So, what's 12 times 6? 72, good. Alright. So that would be 180 plus 144. Which would give you a total surface area of 324.
So that's the entire surface area?
That's it. Okay. Now, in your book, if you'll flip over to 270, you can see a word problem. All right. If you're watching the video, I don't have a way of throwing this on there right now, but just make sure you're following along in your book and you can see what I'm talking about. There is a word problem, all right, and it's their favorite word problem when it comes to surface area. They love using this example. That's why the book throws it out there front and center very first. It says, Joanna is wrapping a present in the box shown. Find the amount of wrapping paper in square inches that Joanna needs, not counting overlap. All right. Wrapping paper goes where on a box? The outside. The outside surfaces, right? That's why they love it for surface area. You don't take wrapping paper, wad it up, and stuff it inside the box. All right? And so wrapping paper and paint are their 2 favorite examples. Okay? So I'm going to draw the picture that they have in the book. All right, they have all right. So, if we're going to be wrapping this, is that going to be total surface area or lateral surface area?
Total surface area.
Total surface area. All right. When you give someone a gift, do you just wrap the sides?
Yes.
All right. There's no point in wrapping it then. They'll just look at the top or the bottom and figure out what it is, right? We got to wrap the whole thing. For wrapping every surface, that's total surface area. So, total surface area is the perimeter of the base times the height plus 2 times the area of the base. Okay? Formula's still on the board. I'll have you write it down later so you have it with you. All right. So, first thing we need to do is the perimeter of the base. Okay? Now, I'm going to do this just to make my life easier. I'm going to redraw the base. Okay? What are the 2 numbers that go with the base? 1 and 8. Get there. All right. So, most of you at this point are going to do everything right, and you're going to still miss this. All right? Because they're not all in the same measurement, right? We've got 2 numbers in inches and 1 number in feet. Okay? A lot of y'all get so into solving the problem that you forget to look at the numbers. This is 1 foot, which is actually what? 12 inches. All right, so we need to solve for the perimeter of this base. So that would be 12 and 8. What is this right here? That's another 12. And this? 8. What's the perimeter of that? 12, 8, 12, 8. What? 40. Good. Times, what's the height of the prism? 6. Good. Then 2 times, we need the area of the base. So that would be base times height. 8 times 12. Base times height. What would be 96? All right. Now, at this point, you can do it by hand or you can just plug it into your calculator. Either way is fine with me. I'll do it by hand. This would be 240 plus 192.
Wait, I thought 6 was the height.
It is.
And why did you want 8?
I'm looking at that was the area of the base. So we're just looking at the base there. All right, so that would be, what, 340, 432, I believe?
432.
It's our area code. Hey, here we go. That would be the total surface area. Okay. So we need to make sure, okay, when we're solving for area of the base, which we're going to need that, right? We got to be able to know the difference between when they're asking for height of the prism and when they're asking for height of the base. In this original formula, this original H is talking about height of the prism because we're talking about the whole shape. But when we go to solve for area of the base and the formulas up here talk about height, we have to understand that those are talking about just the base. All right? That's why I redrew the base over here to the side, so that I could look just at the base. Cool? Okay, so here's what I want you to do. I'm going to do this on the video here in a little bit, but I'm going to pause the video. On page 271 at the top, there is a your turn problem. Okay? Make sure you read the problem. Okay? Because it's not asking for lateral surface or total surface area. It's asking for something different. So read the whole problem and understand what parts of the shape need to be covered. Okay? Okay, so if you're on the video, you can pause the video and give yourself time to look over that question. Otherwise, you guys who've just been working on it, the first thing you should have noticed is, what is it that we're wrapping in this problem?
The bottom and the lateral faces of the drawer.
Okay, so, but what's the object?
A drawer?
It's a drawer. It's not a present. It's a drawer. Okay? You don't have your book? That would explain it. It's up there. All right, so we're wrapping a drawer. Okay? Now, we can't wrap all the bases of a drawer, right? Because then you would have wrapping paper over the, or not wrapping paper, whatever this paper is. Liner. Yeah, you'd have that over the top of the drawer, which would make the drawer pointless because you could no longer put things in said drawer. So, we are only wrapping the outside, the lateral faces, and the bottom base, right? So, we're going to have to think about it a little bit. First off, we know we're going to do the lateral faces, right? The perimeter of the base times the height, plus, what are we going to add on to that? 1 base. Instead of 2 times capital B, we only want one of those bases. So you can either put 1 times B or just B, like that. That'll give us the outside lateral surfaces and the lower base. So, one of the problems with this particular example is they don't tell you which is the bases. Okay, so I'm going to have to make those up.
However you put it, it's the same answer.
That's what I would think, but like that. All right. So the way I would have done it is I would have said, okay, this is 1 yard. This is 20 inches. And I would have put the height as 9 inches. I think anything higher than 9 inches is a huge, deep drawer. So This is the way I would have put the measurements, okay? If you put them differently, that's fine. You're going to get a different answer. On STAR test, they'll clearly tell you it has a height of 9 inches, okay? So, before I do anything, what should I do? What do I have to fix? 1 yard has got to be changed into inches. 1 yard is 36 inches, okay? There's 12 inches in a foot. There's 3 feet in a yard. 12 times 3 is 36. All right, so yes, it's a very large drawer. Okay, so first thing, I like to redraw the base. It's 36 by 20. What's the perimeter of that base?
90.
No.
112.
112. 20 plus 36 plus 20 plus 36 is 112. So, times the height, which was 9, plus, now we need to do the area of the base. That would be 36 times 20, which is 720. Okay, and we can actually just plug all of this into our calculator. And you get 1,728. Okay, so that would be the surface area that would be covered by the wrapping. Okay, so that is rectangular prisms. Okay, now the next thing we're going to move on to is triangular prisms. All right, but the formulas don't change. All right, the method doesn't really change. Okay, we just have to be careful when it comes to heights. Okay, if you have your book on 271 still, you can see the example we're about to do. All right, we have. Why does it do that? Stop it. It keeps jumping over. I don't know why. Fixed it. Okay. It tells us this is 5. This is 8. This is 3, 5, and 6. All right. So, again, I want to solve the lateral and the total. Okay, so we'll do lateral surface area first. That's just the perimeter of the base times the height. The first thing that I like to do is redraw the base. What's the base of this shape?
The triangle.
The triangle. It's what it's named after. So, I'm going to redraw that triangle. That's 5, that's 8, that's 3. What's this measurement? 5. We can tell we're right there. Okay, so this would be 5 as well. So, what would be the perimeter of that base?
18.
18. 5, 10, 18. Times, what's the height of the prism? Oh, somebody said it. It's not 3. Let's make sure we understand this. This is important. Height of a prism is not how tall it is.
Oh, 6. It's 6.
What is height of a prism?
The area, the
distance between
from
the
base to
two
base.
The distance from base to base. This is how tall, 3 is how tall the triangle is. The distance from triangle to triangle is 6. We have to be able to see that. That's a common mistake that'll cost you to miss problems. So, 18 times 6 is 108. That would be our lateral surface area. Okay. Finally, if we do total surface area, capital PH plus 2B. We already know that capital PH is going to be 108. We just solved that right here. Plus 2 times, we got to do the area of our base. Now, this is the only time that it's different from rectangular prisms. What's the formula for area of a triangle?
Half.
1/2 base times height. It's on the board back behind me. All right, 1/2 base times height. Base and height of what? The triangle. We're only talking about the base right here, right? This is the area of the base. I don't care about this shape up here. All I care about is the base. So, what is the base of that triangle? 8. What is the height of that triangle? 3. 1/2 times 8 times 3. That's 12. Okay. We have to know when they want the height of the prism versus the height of the triangle. All right, so 2 times 12 is 24, plus 108 would be 132. That would be our total surface area. All right, so that's our first lesson into surface areas. Okay, we did rectangular and triangular surface areas. Okay, I'm going to tell you, STAR tests, they typically lean to triangles. Because you can see it takes a little bit more thinking. All right, but at the same time, it's the same process. Okay, let's see. All right, so I'm going to stop the video. All right, thank you for watching the video.